Hello everyone, thank you for watching this session. My name is Peng Tao and I will be talking about Kata Containers when virtualization meets cloud native. And I'm a software engineer at Ant Group, and I've been working on Kata Containers for almost 3 years since the very beginning of its foundation. And I'm a co-maintainer of the project as well. Let's start. So this is today's agenda. Firstly, I will talk about Kata Containers introduction to give some background of what is Kata Containers. Then I'll be talking about Kata Containers 2.0. This is the latest release we have been doing in this year. It has some key features and architecture change that will benefit everyone. Also, I will talk about Kata Containers at Ant Group. We've been using Kata Containers in our production environment for a long time, and we probably have the largest cluster in Ant Group. So I'll be talking about why we use it and what experience we can share with the community. And last, I'll give some future works we have planned for Kata Containers. So first, what is Kata Containers? When we first started the project, we envisioned that the traditional containers isolated by namespace C groups with shared kernel has a key drawback which is that if there is a kernel bug in the host kernel, one container that is constrained by the namespace and C group can exit from its namespace and see other containers and even attack the host kernel. So the basic idea of Kata Containers is to isolate the different containers with a virtual machine. So we put containers in a virtual machine and give each container a separate kernel. So even if there is a kernel bug, the process will be contained in the virtual machine so that it cannot see the other containers in different virtual machine. This is true because the virtual machine interface is an industry validated secure interface, as we have been doing for the infrastructure and the cloud service for many years right now. So the key difference is we have a virtualization layer here. So when we run a container, there is a very common use case is that we run it with a Kubernetes cluster. So in Kubernetes, there is an important thing that is called a pod. So every pod has many containers in it. So then at the left side of the picture, we show that a typical deployment of a Kubernetes cluster in a cloud environment. So the user will apply a virtual machine and install the operating system and the Kubernetes runtime and container runtime there and run its pod in this environment. So as you can see, there are two pods running on the same virtual machine. So the drawback is that if the one pod is attacked by some hackers, the other pod is insecure as well because they share the same guest kernel. But in Kata Containers, we envisioned that a pod is a very good concept for a virtual machine. So we put a pod as the virtual machine as a pod. So in Kata Containers infrastructure, we run the hypervisor and the Kubernetes in a host kernel, and then we run virtual machine as a pod. In it, there is an operating system and all the containers in the pod are in the same virtual machine. So the pod level isolation is lifted from C groups and namespaces into a virtual machine isolation, which is more secure than the traditional one. So with this concept, we created a Kata Containers project, and we've been doing it together with the Kubernetes community. We have added several key features to Kubernetes. The first one is the runtime class resource. So in a Kubernetes cluster, user can just define different runtime classes. A runtime class is to say we want to run a pod. That is to say we want to run a pod with different runtime. The typical runtime, the default one is the runc runtime. And we can define a Kata Containers runtime. So users can just say in the user's YAML file, pod YAML file, to say that I want to run this pod with Kata runtime. So Kubernetes will know this and schedule the pod on the Kata enabled node and run it with Kata runtime. So this is even before the Kubernetes 1.14, and now it's generally available in all Kubernetes releases. So, and this one is the Kata Containers architecture. At the left side, this is the original Kata Containers 1.x architecture. We have changed it a bit, but I'd like to start with the old one, so that user can know why we do it. At the left side, we have a Kata shim, and it is to proxy all the container IO stream into the virtual machine. And we have a Kata runtime process that is to translate all the OCI command and spec into Kata defined gRPC calls through a pod level proxy process. And this process will help us to communicate with the Kata agent inside the guest. And the Kata agent is a long-running process in the guest to manage the actual container inside the virtual machine. And we have been using a gRPC over Emacs through the serial port connection, because the serial port can only be used by one consumer, and we want to use it by different process. As you can see, there is a Kata shim process and a Kata runtime process. So this is the original architecture of Kata Containers, and because Kata Containers is OCI compatible, we can support different orchestration systems. We can run it with Docker, we can run it with Kubernetes, and we can even run it with OpenStack. There are some projects to run Kata with OpenStack infrastructure. With that in mind, we have involved the Kata Containers architecture. One drawback, as you might have noticed with the 1.x architecture, is that we have a Kata shim process and a Kata runtime process and a Kata proxy process, both running on the host. And let me explain it in more. The Kata runtime process is a per pod process. We use it to send some control command to the agent, and it will exit when the control command is finished. But we need to keep the Kata shim and Kata proxy process all running all the time with the life cycle with the same life cycle of a pod sandbox. So if we have in the above picture, if we have a CLI client such as Kubernetes, it will use CLI interface to call container D, and container D will spawn a container D shim for every container, and we will spawn a Kata shim for every container, and we also need to spawn a Kata process for every pod sandbox. So if we have two containers in one pod, we will need to at least maintain two container D shims and two Kata shims and one Kata proxy shims on the host. So there will be five processes non-running processes to manage for a simple pod that only has two containers. This is very problematic if we want to put Kata in production, because if any shim dies in the middle, we need to kill the corresponding shims. And if the Kata proxy dies, we need to kill all the shims and also the virtual machine. So when we first put Kata containers in production, we see a lot of problematic issues like this, and then drove us to see how we can improve the situation. So then we discussed with the Container D and Kubernetes community. So we came up with architecture that is more cleanly. So as we define a runtime v2 shim API of our Container D. So Kata containers just need to implement the shim v2 API as a non-running process. So we combined all the 5 process, non-running process, and also the short-lived Kata runtime process into a single daemon on the host. So as you can see, the architecture is way much more cleaner, and as we did the migration, we have changed all our production in Kata into the shim v2 architecture, because it is more easy to manage and this process to manage these processes. So after looking at the Kata containers architecture, let me introduce a bit of history of Kata containers. Although Kata containers is only a little more than 2 years, we have been doing it for almost 5 years now, because as early as May 2015, a team at Intel announced a clean containers project, and a team named Hyper, that is us before we were acquired by Ant Group, and the Hyper Group, the Hyper company, announced a runway project. The two projects are announced almost the same day, and they aim to solve the same problem that a traditional runC container is not secure. So, and they choose the same approach to do it, to do it, because we both want to use the virtualization layer to harden their isolation. So as the two projects separated being developed and continue running for almost 2 years, we meet with the Intel team and decided to try to merge the two projects into a single one, so that we can better improve prospect the virtualized container community. So we came to the OpenStack Foundation that is now renamed into OpenInfraStructure Foundation, but that was OpenStack at then. And the date of that December 2017, Kata Containers and runV merged into Kata Containers, and it is hosted in OpenStack Foundation as their first pilot project, because at that time OpenStack Foundation is trying to expand its scope into open infrastructure. So we were the first pilot project of OpenStack Foundation, and one and a half a year later, and as in April 2019, Kata Containers was confirmed by OpenStack, by the OpenStack Foundation board, and the second project of OpenStack Foundation. And the first project of OpenStack Foundation is the OpenStack project. So OpenStack, at that time, OpenStack has only 2 projects: the OpenStack project and the Kata Containers project. And as Kata evolves, in this year, in the October, we released the 2.0 release of Kata Container, and also OpenStack Foundation is renamed into OpenInfra Foundation now. So that's the main history. We are still maintaining the 1.x release of Kata Containers, but now the main development forces have been migrated to the 2.0 release. So let me talk a little bit on what's new in 2.0 release. The first one is we have rewritten Kata agent. That is the agent running inside the virtual machine. We have rewritten it in Rust, so that helped us to significantly reduce the memory overhead of the agent. We reduced it from about 10 megabytes into about 300 kilobytes. So then helped us to make Kata containers usable in some memory constrained environment, such as functional computing and container as an infrastructure service. Also, we have simplified the agent protocol from gRPC protocol into TTRPC protocol, because gRPC is mostly HTTP protocol that is introduced mostly for cross-host communication. But because the runtime and the agent, the virtual machine, are all on the same host, so we improve it into a much simpler TTRPC protocol. That is gRPC without HTTP mostly. And also we have added a new component that is Kata Monitor. We use it to improve the observability and the manageability of Kata containers. I will talk about it a bit more later on. And also because we have changed the agent protocol, we added a new component called agent control to the project to help validate the agent API. Also, we have moved to a mono-repo model. All the code and document repositories are consolidated into one single repo. Before that, we have different repo for different components. For example, the Kata runtime has its repo, the Kata shim has its repo, and the agent and proxy all have its own repo. Now we have consolidated all this code into a single repo. So the maintenance management, the maintenance burden is much less now. Also, the Red Hat company has introduced a new virtualized file system that is called Virtualization into QEMU, and together we pushed the Virtualization kernel module into the mainstream kernel community. And in 2.0, we have set the default file system sharing method into Virtualization, so we can have better POSIX compliance compared to previously used Virtual 9P. And also we updated the cloud hypervisor support to the latest one, even if it is not released right now. But the latest one is feature-wise on par with QEMU, so we updated the cloud hypervisor support. And also, we moved to support solely shim v2 API rather than the CLI command line to reduce the attack surface. This also means that Kata shim and Kata proxy used in 1.x are no longer required. We also updated the Guts kernel to the latest stable at the moment of the release, that is 5.4.71. And also we updated QEMU to version 5, because at that time version 5.1 has a bug that prevents us from using vSOC, so we used version 5 at that time. So this is the illustration of the Kata agent and gRPC. We moved from Golang agent plus gRPC into Rust agent plus gRPC. The benefit is that the RSS of the Kata agent is reduced from 11 megabytes into about 300 kilobytes. And also, as I mentioned, we introduced a Kata monitor component here. So that is because right now the container metrics is not enough for Kata containers, because besides the container itself, we have an agent, we have a guest kernel and a hypervisor, and also a shim on the host. We want to expose all the status and metrics of these components. So we added a Kata monitor component. Then it is a per host daemon, and it will connect to containerd Kata shim v2 with a separate socket, and it will expose the Kata's metrics via permissions protocol. So any user with permissions can consume the Kata metrics and show it. And with that, this is the architecture of VirtualFS. This was introduced by Red Hat first, and we worked together with Red Hat, and there are Alibaba cloud developers working together with us as well. We together pushed the VirtualFS kernel module that is here, VirtualFS Fuse and the VirtualFS PCI driver. We pushed this into the mainstream kernel. And as shown in the architecture, it's a little bit complicated, and I'll just walk through a little bit of it. And firstly, it's a fuse file system, so applications can see all the contents via a fuse mount point inside the guest, and the fuse protocol is sent through a VirtIO queue to the host, and on the host there is a VirtualFSD process. Then it simulates a vhost fuse device. With this vhost fuse device can be used to pass all the host file system data and metadata here. And also there is an advanced feature of VirtualFS that is to enable a DX support. So with DX, the guest can use the host memory and its page cache. So there will be no VM exit when guest wants to access the host memory via this. So it's a bit complicated architecture, but we have better performance and better POSIX compliance with this VirtualFS. So we made it default file system share method in 2.0. And talking about Kata Containers and Ant Group, the main question we want to ask is Kata Containers only suitable for untrusted workloads? Because we constrain users container in a virtual machine because we want to protect the host and other containers. But is it the only use case for Kata containers? We do not think so at Ant Group. So no, the question is no. But I'll talk about why we think that. So one thing we value very much of Kata containers is workload isolation. Before Kata containers, with the conventional containers workload, we have four containers on the same host, and different containers have different priority. For example, container A is high priority and container C is low priority. Container B is high priority and container D is low priority. But as we can see in the picture, container A and container C may share some critical routine in the host kernel, and container B and container D may share some critical routines in the host kernel as well. So if container A wants to do something, but the critical routine is being taken by container C, container D's response time would be delayed. This is very important in our infrastructure because there are some tasks we never want to delay, but we still want to run different priority tasks on the same host to improve the resource utilization ratio. So before Kata containers, this is a big problem for us in production. So with Kata containers, we collocate the high priority and low priority workloads on the same host, but we isolate the low priority tasks in Kata containers. So the blue square one is the high priority. We still run it with traditional run-C container, but the low priority tasks, it may be an offline computing task or some low priority online tasks. We put it in Kata containers, so they do not share the same kernel resource on the host, and the response time of the high priority task is not impacted by the low priority tasks. We do it because the key of using Kata containers is to have a balance between resource isolation and resource efficiency and also the common usage of Kata containers. So this is how we use Kata containers and how we balance between the different goals. So let me talk a bit about the Kata containers resource improvements we have and Ant Group. The first is we are using a Rust VM hypervisor. We do not use QEMU because QEMU consumes much more memory than the Rust hypervisor, and also the Rust is a memory safe language, so we have less maintenance problem than QEMU. Also, as we have stated that we have rewritten Kata agent from Go to Rust and replaced the gRPC with tgRPC. Also, one thing I didn't mention is that we replaced Virtual 0 with vSock, because with Virtual 0 we have to use the Kata proxy process, and we want to drop it, so we use the Virtual vSock right now, and we have replaced 9pfs with Virtual FS. With these replacements, we have improved the Kata containers resource footprint much better now. And also, as we put Kata containers in real life usage and in production, we have some requirements from internal teams such as the SRE team. They do not, while Kata containers is secure, it is less manageable than a virtual machine. So we added an ops channel to the virtual machine. So the SRE team, the SRE guys can manage and look into the virtual machine while the ops channel, and the ops channel is not exposed to the real users, which is limited by the Kubernetes APIs. So if something goes wrong in an online environment, the ops can just log into the virtual machine and see what's going on there. This helps the online problem diagnostic much better now. And also we have implemented hot upgrade for Kata Sim v2 process and Kata agent. This is also an internal requirement from our SRE team, because everything we deploy in our production, we want it to be upgradable. So if anything goes wrong with one version of either Kata Sim v2 or the Kata agent, we can fix it and hot upgrade without affecting the running workloads. So we are also looking at upgrading the hot upgrading the Rust VM and the hot patching the guest kernel, but that is still working in progress. So this is what we are building inside Ant Group. We have built a so-called trust native infrastructure, and I didn't mention that I am in the trust native business unit of Ant Group. So the infrastructure we built is called trust native infrastructure, and we manage all the infrastructure of Ant Group. So as we defined, the key of trust native infrastructure is that we not only want it to be stable, we want it to be trustable. So we want the users to be confident of our infrastructure, and we not only we want them to trust each other, we wanted to trust the infrastructure, and to do that, we need several key technologies to make them aware that their content is not affected by others. So Kata Containers runtime is one of the key technologies we are deploying in the trust native infrastructure. So after talking about Kata and Ant Group, let's see what's next for Kata Containers. We have discussed it in the PTG last 2 weeks ago as well. We want more isolation enhancements for Kata Containers. We also want to improve container image operations. This means that right now the container image is pulled and unpacked on the host, but in a cloud vendor case such as the Alibaba cloud, all users' image cannot be shared because their data must be isolated. So the container pulling and unpacking operation must be done in an isolated environment. So in Kata Containers, we want to support the use case and move the container image pulling and unpacking operation into a sandbox environment. And also we want to improve the containers IO stream. Right now, a container IO stream must be copied for several times before it can reach out to the user. We have some ideas to improve it, to have less copy in the process. And also we are working together with the gvisor team to implement a general port forwarding framework for different virtualized containers. In the Kubernetes, we have a KEP, Kubernetes enhancement proposal that is being discussed for this. Also, we are looking at improving the debuggability of Kata containers. Right now, we put user container in a virtualized container, and we want to provide some advanced interface for users to better diagnostic their containers. So that's all for the next. And at last, this is the website we have a website for Kata Containers, that is katocontainers.io, and this is our GitHub organization, GitHub/Kata Containers, and also we have an IRC free channel and also a a snack that is bridged to IRC. So anything sent to our Slack channel is sent, and all the IRC channel is synced from each other. Also, we have a Twitter handle and a mailing list. So if you have any question, or if you want to try Kata Containers, feel free to get in touch via any method you like. So thank you everyone, that's all for my session, and if you have any question for Kata Containers, feel free to post on, I think there is a Q&A session for this as well. I'll be answering questions there. So thank you.